Hi, welcome back to the third and final day of the course. Today, we're going to cover Spark actions and transformations in much more detail. So let's jump in. Let's take a deeper dive into transformations and actions. A little bit of background. Recall that RDDs support two types of operations, either transformations or actions. Transformations create a new RDD from an existing one, and actions return a value back to the driver program. Transformation RDDs are lazy. They're only computed or read into memory when a result is required. We're going to see some examples in the next few slides, and you've already seen some examples. RDDs are recomputed each time an action is run against it, but you can call persist or cache to avoid recomputing. I think this is easy to imagine, right? If you've got an RDD that you're looping through or reading more than once, you'll want to cache it to avoid recomputing it each time. Here's a couple of concepts by example. In number one, we're creating a new RDD through the text file function call. In row number two, we're using a transformation API called map, where we're creating a brand new RDD. In number three, we're calling an action, reduce. So now at this point, the rows RDD, the RDD created in number two, is computed. And it might be computed across different worker nodes if you've deployed this in a cluster. Finally, in number four, if we want to use the rows RDD more than once, it could be a really good idea performance-wise to cache it. Actions. Actions aggregate all the RDD elements using some function such as the previously seen reduce. Actions return a final result back to the driver program. You can see the latest transformation functions and action calls here at these URLs, and I'll include this as a link in the section closing notes as well. So with this introduction, let's get into some more examples of transformations and actions. Let's take a deeper dive into Spark transformations. I'm going to start by firing up IPython Notebook with PySpark here. In the following examples, we're going to be using a new data file. It's the baby name CSV file that we downloaded previously in this course. I've opened it up here in Sublime, and I just wanted to show you what it looks like. We've got columns of year, first name, this is the popular names, the county of New York that it occurred, the type of baby, is it a male or female, M or F, and the total number of counts, or the number of times that name appeared in a particular county in New York. Anyhow, this is the data file we're going to be using as we take a look at more examples of Spark transformations. I can see now that IPython Notebook has started up. So let's create a new notebook. The kernel's starting. I've got the baby names CSV file in the root directory of where I started IPython Notebook. So I'm going to call it, I'm not going to call that function yet. What I'm going to do is create a new RDD for baby names. I'm going to hit Shift Enter to run this. And then I'm going to call the first transformation that I want to talk about, and that's map. This is probably the most popular transformation there is. So let's run this, and I'll describe it in a little bit more detail. Map, as you should expect by now, creates a new RDD. It takes an argument of a function, and what that function does, or what map does, is it applies that function to every element in the existing RDD. So in this case, we've got the baby names RDD. We've called map against it, which will apply this function to every element in the baby names RDD, or in this first example, to every row in the CSV. Okay, so we've got a new RDD now called rows. And I'll show you, it's kind of nice every once in a while to just, especially in the shell, to take a look at the results of that so far. So let's loop through and print it out. And we should see this first name column, because we're passing in an argument of 1 to the row, and the tuples that are produced, or in the RDDs, it's going to be 0 index based. So if we wanted to see the first row, we'd pass in row 0. Okay, so here's all the first names in the rows RDD. So again, what map does is it takes an existing RDD and it applies a function to every element in that RDD. Let's continue with another example. And another transformation is called flat map. So it's got a name very similar to map, obviously. And I think it's helpful to describe when we compare it to map. Let's create a parallelized list of 2, 3, 4. And we're going to pass flat map to it. I'm going to run this. And there's the results. Let's compare this to map, okay? Here we can see the difference. Flat map is really similar to map because it applies a function, this function here, to every element in the RDD, but flat map flattens the results. See how this is just a single list here, whereas map has a list of lists. So flat map will flatten things here. This can be really helpful when you're dealing with data sets that might have some hierarchy to it, like in particular JSON. So we'll cover that more later on, but that's flat map. And I also, before we move on to the next transformation, I want to call out one thing that I'm doing here, and that's calling collect, which is actually an action and not a transformation. So I'm calling collect because I want to see the output of what's happening here. It's easier to explain that way than compared to up here when we started off by not passing in collect. We're not really sure what's in the RDD. Remember, when we're doing these transformations, the RDDs are lazily initialized. So when we call an action is when they actually are read and processed. Make sense? Okay, good. Let's keep going with the next example of a transformation, and that is filter. We've seen that one before, but let's call it on a new data set. I'm imagining the name Michael is going to be pretty popular in New York. Let's find out. Okay, so there's a bunch of rows then with Michael in it. And that is what we have done. Filter, again, takes a function or lambda as an argument, and we can use that to filter out the elements that meet this lambda's condition. So in this case, it's just all lines for every element in rows that have Michael in the line. And then again, we're going to pass in collect because I want to see the results. These are all very, very popular transformations. Now the next one that I'd like to go through is map partitions. So we're going to enter part of transformations here that are really functions or transformations or tools for performance optimization if you have the resources available. You know, if you've got a big cluster, this one's going, map partitions can really make a difference. We're not going to see a huge difference when we're running on my laptop here, but I just wanted to cover it for you because we're going to be setting up a cluster later on in this course, and it's just good to know the differences here. Map partitions is the exact same as map, but it allows us to pass in the number of partitions to use across the RDD. And remember, the second word in the RDD acronym is distributed. So partitions allows us to break up and distribute the RDD and have them processed across workers. So let's take a look at some code. First, I need to set things up. Okay, so we're going to create a new range or a new list. It's going to be 0 through 9, and we're going to break this up across 3 partitions. That's this argument here. And then we're going to pass in a function to map partitions, and then we're going to output the results. So when we do that, we have now summed each of the elements or each one of the numbers in the range across 3 partitions. So one way to see how that's happening or what that means is here. I've put this together for us. This won't run in the notebook, but I think it will help show how that result happened. So in partition 1, we're adding up these elements. Partition 2, we're adding up these elements. And finally, the third partition are these elements here. So this map partitions is a way to break up your RDD and specifically process them across your cluster. Let's take a look at another example. We're going to start off similar. And then we're going to call map partitions, but we're not, at this point, we haven't expressed the number of partitions to use. So here we express 3. Now in this example, we're not specifying anything. So the output is this. Now, what happened here? Well, I'm going to show you. And again, this won't run in the notebook, but I think it helps to describe what's going on here. So in partition 1, we've got 1, 2, 3, 4, 5, 6, 7, 8. And then the last partition is 8 plus 9 equals 17. So this must tell us that there's 8 partitions by default. And I wonder if there's a way that we can find that out. Well, I can tell you there is. If we use the Spark context, there's a default parallelism call that we can see the default number of partitions, which is 8. Okay, so how did we know that there was 8? Or tell me a little bit more about what's happening here. So when we're trying to do some performance optimization, you typically want 2 to 4 partitions for each CPU core in your cluster. So normally Spark tries to set the number of partitions automatically, as we see in this example here, based on your particular hardware. So I can tell you the laptop we're running on has 4 cores. So that's why 8 is the default on this. So does that make sense? What I wanted to show you here then is just to recap before, we'll take a break and then we'll move on to the next section of transformations. But just to recap, we covered some really common transformations, map and filter and flat map. And finally, we showed another transformation that you can use as you start to think about performance optimization in your Spark code. So I'm going to take a break here, and maybe this will give you a chance to run some of this yourself. At the very end of this section, I have all the IPython notebooks available for download. So you can jump to that section if you want to download the notebook, and then we'll pick it up with more transformations in part 2 of transformations. All right, thanks for hanging with me, guys. I know that last one was long. This one is going to be much more short and concise. We're just going to cover 3 transformations that are really helpful when we're combining RDDs, or we're comparing RDDs, or we're contrasting RDDs. So to start, let's create a couple of RDDs that we can do straight from the shell or in our notebook here. We'll create 1, and then we can create 2. Recall that parallelize creates RDDs, and we can pass in the amount of partitions we want to use as well. We're just going to use the default here for these 2 RDDs. Let's make sure everything's okay. So I hit Shift Enter to run that. Everything's looking good. So now let's use our first transformation for this section, and that's union. Union takes 1 RDD, and the argument to it is another RDD. We're going to use collect to see the results in a more clear way. As you can see and probably guess from a name like union, this is a way to combine 2 RDDs. All right, let's keep going with this. Let's create some new RDDs just for some examples here. I'm going to call them 1 and 2 again. We'll create, well, let's leave 1 as it is. Let's update 2 to change the range a bit. Make sure that's okay. And then the next transformation I want to talk about here is intersection. So let's take a look at what intersection does. And you can see hopefully that it returns, well, it's going to return because we called collect on it, a new RDD that contains the same elements originally found in both RDDs. So we know that 5, 6, 7, 8, and 9 were in both RDDs. Okay, so we're moving along here. Here's the next one we'll do. We'll keep 1 the way it is. Let's create another one here for 2. I guess it's the same as before. So in this example, let's talk about distinct. So let's see what this looks like, and I might have to adjust this code a little bit here. Yeah, so let's use 1. Let's combine them, but then let's find the distinct. So in this case, the elements between the two that are distinct are 1 through 14. And I don't know why that doesn't really make much sense to me. Let's take a look at this a little bit more. Oh, so range is 1. Yeah, actually, let me update this second one here because it doesn't. I was hoping for a little bit difference in between the two. What's the distinct ones? Well, let's take a look at what it looks like without. Oh, that's what it is. We need to show the differences without distinct. Sorry, guys. So in this one, we can see that they're duplicated, right? When we combine using union, we combine the two, and duplicates are maintained. So we've got 2 9s, we've got 2 8s, and distinct. Sorry, guys. Yeah, and this is what distinct does in this particular case is that it filters out just the unique elements between the within the RDD. So we've seen distinct before, and now we'll see it again here. And sorry for the confusion there, but distinct just pulls out as expected. I don't know if I didn't have enough coffee today or what, but as expected, distinct just pulls out the unique elements within an RDD. So we created a new RDD here, and then we call distinct on it. We'll call this collect action so we can see the results. So without distinct, we create a new RDD here, and then collect on it, and it contains the dupes. Okay, so this was part 2 and just the section on comparing and contrasting and combining RDDs. In the next section, we're going to talk about keys and really highlight all the cool stuff we can do with Spark and running over pair RDDs. Okay, in our third part of Spark transformations, we're going to work with the key functions. Key functions are transformations that we use when we have a key value pair RDD. So we're going to start our discussion off here by, well, let's start over for clarity on this one. Let's reload baby names into rows, and then let's create pair RDD or key value pairs of names to the counties that they appear. So we're going to use map over every element in rows, and then we're going to create the key pair here. We've got the key, we have the name, and then this is the county. And then we're going to group by that key. We can't really tell what's happening here, so let's take a look at the results. Okay, what we've done then here is we've gone over every element in names to counties, which we've created here. We've had the name and the list of counties that name appears. So for the name Griffin, it has appeared in all of these counties here and more. So that's pretty cool, right? We can group by the key, in this case the name, and we could group them all together where all the counties in this case where they appeared. So that's group by key. Let's take a look at another example. And again, let's start over for clarity. Let's have a filtered rows. You've seen this one before. We'll filter it because we don't want that first row in the CSV to appear. And we know that first row has the name count in it. So we're going to exclude that, and then we're going to split it up again as we've seen in the past. And then let's call in our next transformation example, which is reduce by key. And again, reduce by key operates on key value pairs. And what it does is it allows us, in this particular case, to sum up all the counts for a particular name across the entire data set. So what we've done is we've taken the name here, and then we've reduced by the key, so we've determined the number of times that the count value, that we've summed all this, and we've summed all the values up for the counts value here. So we've got the key value pair here, name to the count amount, and then in reduce by key, we take the previous value and we add it to the existing value, and we circulate through every element. So in Griffin, regardless of county, we know that the total count is 224 because we've added them all up in this reduce by key function here. So now we know the names across all of New York and the total number of times that they've appeared for this particular time range. So kind of cool, right? So let's keep going because this data here it doesn't really allow us to, it would be nice if we could sort it. So let's take a look at sorting. One example we could use to sort is sort by key like this, where we haven't reduced it yet, so we'll see duplicates here, like Aiden, but it's nice to show for just like illustrative purposes what's happening here. And then we can also do this same thing. Sort by key accepts an argument of true or false, and we can sort in the opposite way. So let's just go back. I'm not even sure if this is going to work, but what the heck? Let's give it a try. So if we go back to this original example with reduce by key, how could we sort that? Let's see what happens. Awesome. So now we've added up. Now we have a list of the most by the key, because the key is the name, of all the times that Aiden, Elia, Aaron, etc. have appeared, and no duplicates, no name duplicates. All right. These keys are really valuable for providing some convenience functions, again, when we've got pair RDDs, and we've seen how to construct them here now, and then calling the reduce by key transformations. We use a simple example of adding things up. So we have a sum of all the counts in these names, and then we even added a sort. So hopefully by now you're feeling much more comfortable and confident with transformations. We're going to stop here and just make sure that you're getting these key concepts out of transformations. Let's start exploring Spark actions now. As you've previously learned, actions produce a result back to the Spark driver program. And also, actions may trigger a previously constructed lazy RDD to be evaluated. I'm going to run through some commonly used actions with you for you to be exposed to have a more understanding of actions. Let's start off with some simple examples. We're going to create a new RDD of names, and then we'll call our first example reduce. Let's see what reduce does. Against the names one RDD, we'll call reduce. We pass in a lambda or a function that says add the current T2 back to T1 in the RDD. So add one element to another is the function that we used here. We can take this a little bit further to show a better example or a closer example to the real world. Let's add names to RDD, and let's just print it out to get an idea of what this is going to look like. So we have a list of lists. We have now created then a word and the length of each word. Let's modify this. Let's flatten this. So as we've seen in the past with flat map, let's flatten it and pull out the second of two arguments in that list, which is the character length, and add it together. So we'll pull it out here, and then we're going to reduce it here. What do you think is going to happen? We're going to add up all the lengths. So 8 plus 6 plus 5 equals 19. So that's reduce. Let's move on to a next one. The next one we'll take a look at is count. We've seen this a few times already. Let's, for example, count names 1. So the total number of elements in the names 1 RDD is 3. This is different from what we've seen in the past when we put in a text file and count returned the total number of lines. So it depends on the type of RDD. Now let's take a look at another one. First. Sometimes it's helpful, as we've seen, to call first when we want to see the columns of a CSV or have a little bit more understanding of a particular RDD. That's not going to work because it's names 1 I wanted to call. We'll cut this one out. So the first element in the names one RDD is Abe. So first is pretty simple. Next, let's move on to take. Take takes the first elements, will specify the number of elements of an RDD. Take works by scanning one partition and using the results from that partition to estimate the total number of additional partitions needed to satisfy the limit. It can be much more convenient and economical to use take instead of collect. So we've been using small result sets here in the examples in this course, but in the real world, when you're using Spark against really large data sets and you use collect, imagine if you're transferring all that data over a network. For example, if you're using the driver or IPython notebook on your laptop and you're connecting to a cluster and you call collect over gigabytes and gigabytes of file, that's going to be really, really expensive. So what we want to do instead is use take if we want to take a look at what's in a particular RDD and get a better idea. We're just experimenting, for example. So let's take a look at take. As I mentioned, take takes an argument. In this case, let's call 2. And let's so we're going to take 2 out of the names one RDD. What happens if we want a sample? Well, Spark provides another action call called take sample. So let's take a look at that. Let's take a look at a new example. Let's create a new RDD. Let's call it teams. And then let's call take sample. Take sample has 2 arguments. Whether or not we want to pass in a Boolean value of with replacement and the total number of samples to take. So, and then a seed value. That's a defaults to none. So let's just take a look at here. We can get an idea. And if we run this one a few times, we should see different results. So I'm seeing different results. So this is another way. Take sample is an action where we want to have a better idea of what's in a particular RDD, but we want it to be random. Okay, let's keep going. Let's let's look at hockey teams. Where I live, hockey's really important and popular to our culture. So let's create some hockey teams. And now let's take a look at our new action, and that's count by key. We're going to create a new RDD here, and we're going to create a key value pair, and then we're going to seed it, start it with the count of 1, and then we're going to call count by key. We'll call out items so it's convenient for us to view. You see what's happening here? So count by key makes it really easy to count the total number of a particular element in an RDD. Wild appears 3 times. Finally, let's wind up our examples of actions by our last one, and that's save as text file. So if we would want to write out our results of an RDD, or in this case, our hockey teams, we could write it out as a text file. Let's see. I don't know why that happened. Let's use this as an opportunity to see what happened. Oh, it already exists. I must have previously run this example, and it won't overwrite. So if we change this to hockey teams 2 and run it, it should work just fine. Now, when you look out at the file system here, you're going to notice something, and it won't be just a file. Let's see if I can find it here. You'll see that hockey teams actually creates 8 partitions. So as we've seen in previous examples and the parallel nature of Spark, when we call save as text file, we're going to write that file out into 8 different partitions. Okay, so this was going to cover some examples of actions, and it should give you a good foundation on what actions do and some of the actions that are available to you. Next, let's move on to another section of the course. But first, we're going to actually take a look at a quick quiz on actions.